Martian life? NASA makes stunning new discovery on Mars. In a breakthrough that could change our understanding of life in the universe, NASA has made a monumental discovery on Mars, stirring excitement among scientists and space enthusiasts alike. The tantalizing question of whether life exists or has ever existed on the red planet has fascinated humanity for centuries. Now, with the latest data gathered by NASA's Perseverance rover and corroborated by other Mars missions, there is mounting evidence that Mars may have once been home to primitive life forms. This stunning new discovery raises profound questions about the origin of life, the potential for life elsewhere in the cosmos, and humanity's future in space exploration. Let's delve into the details of this extraordinary revelation and explore its significance for science, exploration, and the search for extraterrestrial life. Mars, a planet of perpetual intrigue. Mars, often referred to as Earth's sister planet, has been a source of curiosity for astronomers and scientists for centuries. Its reddish hue, caused by iron oxide, rust, on its surface, has made it an iconic feature in the night sky. But beyond its visual allure, Mars has long been considered a candidate for life due to several key characteristics that make it similar to Earth, at least in its early history. Mars has polar ice caps, seasonal weather patterns, and evidence of liquid water in its past. These Earth-like features have led scientists to speculate that the planet could have once supported life. Over the years, various missions have focused on unraveling the mysteries of Mars' geology, atmosphere, and potential for habitability. Despite its current harsh conditions, frigid temperatures, a thin atmosphere, and intense radiation from the sun, Mars might not have always been so inhospitable. A history of exploration. NASA's exploration of Mars began in earnest in the 1960s, with early flybys by the Mariner missions. These early probes revealed a barren, cratered world that appeared, at first glance, devoid of life. However, as technology advanced, so did our ability to investigate the planet in greater detail. The Viking missions in the 1970s were the first to land on Mars and conduct experiments aimed at detecting life. Though Viking's results were inconclusive, they laid the groundwork for future exploration. In the following decades, NASA and other space agencies launched a series of missions that sent orbiters, landers, and rovers to the Martian surface. Each mission provided new insights into Mars' climate, geology, and the presence of water, a key ingredient for life. The discovery of water in various forms, ice at the poles, traces of ancient riverbeds, and minerals that form in water, suggested that Mars was once a much wetter and potentially habitable planet. However, finding definitive evidence of life remained elusive. That is, until the arrival of NASA's Perseverance rover in 2021. The Perseverance rover, searching for signs of life. The Perseverance rover, part of NASA's Mars 2020 mission, was designed with a primary objective: to search for signs of past life on Mars. Unlike its predecessors, Perseverance is equipped with advanced scientific instruments specifically designed to detect biosignatures, chemical or physical signs that could indicate the presence of past or present life. One of the rover's key targets is Jezero Crater, a site that was once home to an ancient lake and river delta. Jezero Crater was chosen because of its rich geological history. The presence of a long-standing body of water increases the likelihood that microbial life could have once existed there. Over billions of years, sediment deposited by the river would have created layers of rock that could contain organic molecules or even fossilized microbial life. Perseverance has been analyzing Martian rocks and soil since its arrival, collecting samples for future return to Earth. Early results from its instruments suggested that Mars' environment billions of years ago could have been suitable for life. But the recent discovery that NASA has now revealed takes these findings to an entirely new level. The stunning discovery: organic molecules and potential biosignatures. In a press conference that captured global attention, NASA announced that Perseverance had uncovered organic molecules in multiple rock samples from Jezero Crater. These molecules, which contain carbon, are considered the building blocks of life as we know it on Earth. While organic molecules can form through non-biological processes, their presence in specific types of rocks, combined with other chemical evidence, points to the possibility that they may have been produced by living organisms. One of the most compelling aspects of the discovery is the type of rock in which the organic molecules were found. Sedimentary rocks, particularly those formed in ancient lake beds, are excellent candidates for preserving biosignatures. On Earth, such rocks often contain fossils of ancient life forms. NASA scientists believe that similar conditions may have existed on Mars, providing an environment where primitive life could have thrived billions of years ago. Furthermore, Perseverance detected certain minerals, such as sulfates and clays, which form in the presence of water and can trap and preserve organic molecules. This adds further weight to the argument that Mars once had a stable, watery environment capable of supporting microbial life. Could this be proof of life? While the discovery of organic molecules is a huge step forward, NASA has been cautious in its interpretation. Organic molecules alone are not definitive proof of life. They can be produced through abiotic, non-living processes, such as chemical reactions between water and rock. However, the context in which these molecules were found, along with the specific chemical signatures detected, suggests that they may have been formed by biological processes. NASA scientists are careful to emphasize that further analysis is needed before they can definitively claim that life once existed on Mars. To make a more conclusive determination, the samples collected by Perseverance will need to be returned to Earth for detailed laboratory analysis, where more sophisticated instruments can scrutinize them for signs of life. This is where the Mars Sample Return Mission, a joint effort between NASA and the European Space Agency, ESA, comes into play. The Mars Sample Return Mission, bringing Mars to Earth. The Mars Sample Return Mission, scheduled to take place in the late 2020s, will be one of the most ambitious undertakings in the history of space exploration. The plan involves sending a spacecraft to Mars to collect the samples that Perseverance has been gathering. These samples will then be transported back to Earth, where scientists can examine them with state-of-the-art technology that is far too complex to send to Mars aboard a rover. The ability to analyze Martian samples on Earth will be a game-changer. Scientists will be able to search for minute traces of life, including fossilized microbes or chemical compounds that could only have been produced by biological organisms. This could finally answer the question of whether life ever existed on Mars. The Mars Sample Return Mission will not only help confirm or refute the presence of past life on Mars, but it will also provide invaluable data for future missions, including potential human exploration of the planet. Understanding Mars' geological history, climate, and potential hazards will be critical for any human settlement efforts. The implications of Martian life. The discovery of potential life on Mars would be one of the most significant scientific discoveries in human history. It would have profound implications for our understanding of biology, the origins of life, and the potential for life beyond Earth. If life could arise independently on Mars, it would suggest that life might be common in the universe, occurring wherever the right conditions exist. This would also fuel the search for life on other planets and moons in our solar system, such as Europa, a moon of Jupiter, and Enceladus, a moon of Saturn, both of which are believed to have subsurface oceans that could harbor life. It would also intensify the search for habitable exoplanets orbiting distant stars, as astronomers look for worlds with conditions similar to early Mars or Earth. Philosophically and culturally, the discovery of life on Mars could reshape humanity's view of itself and its place in the cosmos. For centuries, humans have believed that life on Earth is unique. Finding evidence of life on another planet would challenge that assumption and raise new questions about the nature of life and its potential diversity across the universe. Preparing for human exploration of Mars. NASA's discovery also has direct implications for future human exploration of Mars. Understanding whether Mars was once habitable is a key factor in assessing the risks and challenges of sending humans to the red planet. If life once existed on Mars, it is possible that remnants of that life, or even dormant microorganisms, could still exist in the planet's subsurface. This raises questions about planetary protection, how to ensure that Earth life doesn't contaminate Mars, and vice versa. In addition to the scientific precautions, the discovery of ancient life could inspire new generations of explorers and scientists to pursue careers in space exploration. Human missions to Mars, which NASA hopes to achieve in the 2030s, will be the next great leap in humanity's exploration of space. These missions will rely on the data collected by rovers like Perseverance to guide landing sites, resource extraction efforts, and strategies for surviving in Mars' harsh environment. Conclusion: a new chapter in the search for life. NASA's stunning discovery on Mars marks a watershed moment in the search for extraterrestrial life. While we are still at the early stages of confirming whether life once existed on the red planet, the evidence gathered so far is compelling and points to a planet that was once much more Earth-like than previously imagined. The discovery of organic molecules in ancient rocks, combined with the potential for preserving biosignatures, suggests that Mars could have hosted microbial life billions of years ago. As NASA prepares for the next phase of exploration, including the return of Martian samples to Earth, we stand on the brink of answering one of the most profound questions in science. Are we alone in the universe? Whether life on Mars is confirmed in the coming years or remains an open question, the search for life beyond Earth is entering an exciting new era, and the implications of this discovery will reverberate for generations to come.